This is part 2 of the lecture on adjusted odds ratio. The odds ratios we have been talking about so far are unadjusted odds ratios or crude odds ratios. The unadjusted odds ratio is computed from a 2-by-2 contingency table, showing the relationship between the disease and the risk factor of interest without considering their relationship with other variables. On the other hand, e to the beta in the multiple logistic regression model is an adjusted odds ratio in that the association between the disease and the risk factor is adjusted for their relations with some other variables. Let's look at an example of unadjusted and adjusted odds ratios of self-reported health by marital status. This is a contingency table, comparing self-reported health between those who are divorced or separated and those who are currently married. The data are the same data used for logistic regression shown in an earlier slide. This data set has 557 persons above age 20 who are divorced or separated, and among them, 163 said their general health condition was fair or poor. The data set also includes 2,369 currently married persons, among whom 454 said their general health condition was fair or poor. An odds ratio of 1.745 means that the odds of being self-reportedly unhealthy for divorced or separated persons is 74.5% higher than the odds for those currently married. A corresponding adjusted odds ratio is shown in this table as shown earlier. Beta for the divorced or separated is 0.4955 as indicated in the red rectangle. The reference category is currently married, and e to the beta, that is, e to the 0.4955 power is 1.641, which is the estimated odds ratio of being self-reportedly unhealthy between those who are divorced or separated and those who are currently married, adjusted for gender, age, race, ethnicity, and education. Why is this number, 1.641, considered an adjusted odds ratio? Let's think about two cases in the dataset, I and H. The two persons have the same gender, are at the same age, and belong to the same race/ethnicity group, and the same educational category, with one difference. Individual I is divorced, and H is married. In terms of the logistic regression model, they have the same values for all x's, that is, all independent variables except for x9, which is the binary variable for being divorced or separated. The value of x9 for individual I is 1 and that for individual H is 0. Now, the left-hand side of this equation is the ratio of the odds of being self-reportedly unhealthy for individual I to the odds of being self-reportedly unhealthy for individual H. In the logistic regression model, the odds is the exponential function of the linear combination of independent variables. So, we get the equation at the top. Both the numerator and denominator can be expressed multiplicatively like the second line of the long equation. Now, let's look at the numerator and denominator in the second line. Both have e to the alpha, which can be cancelled out. Also note that I and H have the same gender. So, the second term in the numerator and the second term in the denominator are identical and can be cancelled out. And I and H are at the same age. So, the third term in the numerator, and the third term in the denominator, are cancelled out too, and so on. So, as shown in the third line of the equation, what remains is the term related to the ninth variable, for which the two individuals are different. I is divorced and H is married. Because x9 is the binary variable for being divorced or separated and H is married, xh9 is 0, so the denominator becomes just 1. Because I is divorced, xi9 is 1, so the numerator becomes just e to the beta 9, as seen in the fourth line. In the logistic regression results, beta 9 was estimated to be 0.4955, and e to the 0.4955 is 1.641. So, 1.641 is the estimated odds ratio between those who are divorced or separated and those who are currently married when both have the same profiles, with respect to gender, age, race, ethnicity, and education. The example of adjusted odds ratio that we just looked at was about marital status, which is a categorical variable. Let's look at age as an example of a numerical independent variable. In this regression result table, beta for age is 0.0206, and e to the 0.0206 is 1.021. What does this 1.021 mean? Now, let's think about two individuals, I and H, again. This time, they have the same profiles with respect to gender, race/ethnicity, education, and marital status. But their ages are different. Individual I is 41 years old, and individual H is 40. They have the same values, for all x's, except x2, which is age. The value of x2 for I is 41 and the value of x2 for H is 40. Again, the left-hand side of the equation is the ratio of the odds of being self-reportedly unhealthy for I to the odds for H. Just like in the example for marital status, the ratio is simplified to the ratio of e to the beta 2 times 41 to e to the beta 2 times 40 because the two individuals have the same profiles except for H, so that all other terms in the numerator and denominator are cancelled out. Following the formula for exponential functions, this ratio becomes e to the beta 2 times 41 minus 40, which is 1, so we just have e to the beta 2. Beta 2 was estimated to be 0.0206, according to the logistic regression results, and e to the 0.0206 power is 1.021. So, it is estimated that a person has 2.1% higher odds of being self-reportedly unhealthy than someone who is 1 year younger if the two persons have the same profiles of age, race/ethnicity, education, and marital status.